Okay, so I might as well get started then, nice and promptly. So you're all very welcome. Thank you so much for joining us this evening. This is an event part of Engineers Week, so there's lots going on all over the place if you want to check out any of the other stuff that's happening. So this event obviously is hosted by I-LOFAR here in Birr. It's part of our Astronomical Midlands, our ASTRONAUT programme, which is happening thanks to support from Science Foundation Ireland and ESERO Ireland, the European Space Education Resource Office. My name is Áine. So this evening we are delighted to be joined by a very special guest, Dr. Niamh Shaw, who you can see, well, I'm going to point here, but could be here, who knows. Dr. Niamh Shaw. Niamh is many, many things. Niamh is an engineer, a scientist, a writer, a performer, a science, technology, engineering and maths communicator. What doesn't she do? So she's also on a mission to get to space. And she's done lots of stuff to try and make this happen, including participating in a simulated Mars mission, zero gravity flights. She's worked with ESA, the European Space Agency, as well as NASA and many other people and places. So Niamh has lots of experience and expertise on what it takes to get to space and what it takes to live there. So she's going to talk to us a bit about that. We want you guys to participate as much as possible. If anybody has any questions or anything they'd like to chat to Niamh about, you can pop it into the Q&A box down the bottom of your screen. You should be able to see a little Q&A box and a chat box if you guys want to just make some comments or anything as well. And then after Niamh tells us a bit about all of this, we can have a bit of a discussion. And so any questions you have, do feel free to pop them in there and we'll get to them after. So yeah, Niamh, I'll hand over to you. I think you've got
Thanks, Áine. How are you? You good? You're keeping well?
I'm very good.
You're great. We're all over. We're all still stuck at home. so the last time myself and Áine worked together, just so you know, she made a cake for baking in space, which was the visible light spectrum, and it was incredible. It was her way of explaining how I-LOFAR works. So thanks again for that, Áine. That was amazing. Your contribution to baking.
Oh, it was great, and I got
great
to eat cake. So
I got to see you eat cake. We didn't actually get to eat. But anyway, maybe the next time we do baking in space, it'll be in person, please God. But yeah, thank you very much. I'm delighted to be here for Engineers Week. Always happy to come back and work with you and any of the team at DIAS. And yeah, I'm going to just basically take you through what I've learned over the years in terms of habitat design and some of the factors to consider when we think about living off Earth. It's really interesting. It's kind of more a space architect kind of speciality, but I'm delighted to share any knowledge that I've picked up along the way. But a specialist I am not, a communicator I am first and foremost. So I am an engineer and scientist, but in this capacity, I'm just telling you the stories about that. So right now I have shifted and I'm based now here at the International Space University in Strasbourg, purely because logistically what happened to me was it was something I'd been planning before the lockdown. And basically the lease on my accommodation came to an end last November. And when I started looking around at renting somewhere else, it was so expensive. I just went, well, I may as well go to Strasbourg. So I did. And that's why I'm here now. So I have an office here on campus and I'm doing exactly the same job that I was doing in Ireland, except I'm in a different country. But yeah, so there you go. That's the world we live in now, folks, you know. So before I get into it, I can't get over how rapidly things are happening this year in the space sector between space science as well as human missions. So I just found this last week and it's absolutely stunning, and it's a picture of Venus that's taken by the NASA Parker Solar Probe. And the reason I had that up is the last time I worked with Sophie, who's on this call, was for the launch of the ESA Solar Orbiter. And I was DIAS's sort of person on the ground to share the story at Darmstadt at the Operations Centre, and she was at NASA for the launch. But Sophie, can you tell us a little bit more about this picture? Because I just think it's stunning, and I saw it and I just said, oh, well, I have to put that up.
I know, it's gorgeous, and I think you've even seen it before I did. So now, as soon as you showed it me, I'm checking it out. It looks like it's a side on. So, you know, Parker Solar Probe is traveling towards the sun. It's going to get closer than a spacecraft has ever gotten before, which is pretty amazing. But obviously along the way, there's some other sights to see. So it's obviously checking out Venus at the moment, and you can kind of see that gorgeous side-on shot of it. And you can kind of see these streaks that I've been wondering what they are as well. I'm wondering if they're particles in space. You know, you got space dust. There's you know, accelerated electrons and protons that are exposed from the sun, so they might be charged particles from the sun, or maybe even the more nasty stuff like cosmic rays from outside our solar system. So there, you know, the image on the camera is obviously capturing not only Venus but some of the cool space dust out there as well.
Thanks, Sophie. That's great. I knew you'd be able to tell me something about it. I appreciate it. See, I got something out of this talk as well. Thank you. That's
No
great.
worries.
Thanks, Sophie. Thanks. So yeah, so I have to give the nod to that, and I was so appreciative that Dias allowed me to share their story that day from the operations center in Darmstadt. So yeah, okay. So living in anywhere off Earth is kind of what I'm focusing on, and this was given, I saw this cartoon first back in 2015. So putting humans in space is kind of the complete opposite of where we really need to be. It's a very difficult place to keep us alive. So for that reason, we have to think of completely different ways of how to live and how to plan structures and how to feed us and get rid of our waste. So these are all kind of the ideal things, like you don't need to have haircuts, so bald, nearly blind, then you don't have to worry about vision problems in weightlessness, no teeth, so then you don't have to worry about going to the dentist. The older you are, it means that the harder you are against radiation. If you can drive a golf cart, a lunar rover scale. Anyway, it's a little bit tongue-in-cheek, but I like it, and I think it kind of sets up this talk a little bit. So how do we live on Earth, or off Earth, shall I say? You know, so I always go back to this image because to me this is the image that's inspired everything that I do, which was taken in 1968 from the moon as the Apollo 8 was orbiting the moon in advance of ultimately getting our first 2 humans on the surface of the moon. That was 1968, so it's over 50 years ago now, and we've come a long way since, and yet we haven't really. You know, we are still trying to return to the moon, and we've probably spent the last 20 years understanding how microgravity, or the feeling of weightlessness on our bodies has had on our exploration, basically. So if we go right back to what we've learned over the years, so the very first thing that we put into orbit was Sputnik, which was Roscosmos. So that was the first satellite in space. And then the very first person in space was Yuri Gagarin. That happened in 1961. So that's coming up to its 60th anniversary this April the 11th. And of course, he launched from Baikonur, the infamous Cosmodrome, which I was very lucky to visit back in 2018. And then, then of course, you know, it was his relationship with Korolev that led to this amazing achievement, and there was this race for space, and that's what drove all these firsts, and you know, there's all these monuments and everything all over Baikonur praising him. And then the very first woman that was in space was, of course, Valentina Tereshkova in June 1963. And the amazing thing is that Valentina is still alive, and I stood beside her. I totally was just in awe of her. She's one of my heroes, although she's not the friendliest, but anyway, there you go. She can do whatever she likes. To me, she's amazing. And then, of course, from the American side, then we had the Mercury 7 and their attempt. Then the very first person that was launched into space was, of course, Alan Shepard, and then John Glenn then orbited Earth soon afterwards. And then we're into where this talk kind of really starts. Then we're into kind of putting people in space for long periods of time. And then we got into the space station era. And the very first space station was the Salyut 1 from Roscosmos, and they had a series of Salyuts that ran until the 80s. And then they upgraded into the Mir space station, which was a very good space station indeed. And then at the same time, NASA then had their Skylab, which was an inordinately big space station in comparison to the International Space Station. And that ran just for 2 missions because it was damaged upon launch, and they never really got over it. So they only really ever had 2 missions there. But some of the designs they had on that were like amazing, like really groundbreaking. And then the space shuttle. I love the space shuttle. And this is footage from the very last return of the space shuttle, which of course was in July 2011. And once the space shuttle finished its missions, of course, what happened then was anybody that wanted to travel to the International Space Station had to fly from Baikonur. And it was only last summer that we have returned launches from America. That's thanks to partnerships with SpaceX, and then possibly other subsequent companies also offering trips to the International Space Station. So that's with Crew Dragon. And also worth mentioning, thanks to the space shuttle, we also saw our first American woman in space, which was Sally Ride. So let's talk about what are the things that you need to think about if you want to live off Earth. So you kind of really just have to throw out all the rules about how you build houses on Earth and think about them from a completely different point of view. And I find this really, really interesting. So I was lucky to take a few lectures in space architecture. And so Brent Sherwood, who now works for Blue Origin, I'm taking the summary of a lot of his lectures in sharing this with you, because space architecture is of itself an emerging field and fascinating, absolutely fascinating. So what he said to us was, there's kind of 3 things. What is the purpose of the mission? Is it to explore? So that means you're going off. Is it to exploit, as in, is it to kind of gather materials and bring it back? Is it to experience? So is that for like long periods of time living somewhere, or is it to settle? So, and more than likely that's the line of the timeline that you would go, so initially you go to explore, then you go to exploit, then you go to experience, and you go to settle. So if we think about when any human discoveries happened, if you look at the 1500s when Columbus discovered America, of course he didn't discover America. America was still there, and there were lots of people already living there. But from the European standpoint, it was the first time we had found America. And so, that was initially an exploratory mission. Then they went back and they exploited it. Then they experienced it, and eventually people lived there. And it's kind of the same. It's sort of the same kind of timeline. But when you think about looking at celestial objects, and this would be particularly in relation to space stations that orbit Earth. So they're about 300 or 400 kilometers above us in what's known as lower Earth orbit, then to the moon, and then onwards to Mars. And then the factors that you have to think about all the time are, and these are the factors that are the limiting factors of what you can actually design, is gravity. Gravity is going to behave completely differently. You are in the vacuum of space. You have to think about the temperatures, the range of temperatures. You also have to think of the exposure to radiation there. So if we're talking there about cosmic radiation, so once you leave the atmosphere of Earth, you are in extreme danger at all times, just even from cosmic radiation alone. You have to think about what speed you need to go to in order to be able to maintain an orbit around Earth. You have to go at a speed that at an angular velocity, I think it's like 27,200 kilometers per hour, or is it 22,700 kilometers per hour? I always get them mixed up. And the purpose of that is that it overcomes the gravitational force to pull the space station towards Earth, which means that you can orbit Earth, and it puts the astronauts in a state of free fall at all time, which makes them feel as if there is no gravity, which of course there always is. And then dust. And this is particularly relevant to habitats on Mars and on the moon. Dust particles behave very differently. I'll talk about this a little bit more when we get to the moon, but with the lack of atmosphere and a lack of wind, dust particles are actually quite sharp. And they're very, very abrasive. And this was something that hadn't really been considered in the first initial design of spacesuits for the Apollo missions when they landed on the moon. And I was very lucky. I actually managed to see Neil Armstrong's spacesuit in the Smithsonian 2 years ago in Washington. And it's amazing that the moon dust is still on it. Like, it's mad, isn't it? You know, anyway. And then the other thing then, you have to think about when you design buildings or you design structures, you have to think of them from the human end of things. And I'll go into that in a little bit more detail as well, in terms of its proximity, in volume, in terms of like how much volume does the human take up and how much spare space is there, and how much working space, rest space, and then also like operational space is required. The orientation of things. How do you stop people from getting confused? How do you feed them? And how do you get rid of our waste? So these are some of the things I'm going to be looking at. So it is a very dangerous place out there. So even when we just look at the International Space Station, when facing the sun, it experiences temperatures in excess of 100 degrees, and then in the shadow, it experiences temperatures in excess of minus 100 degrees centigrade. So that means every time an astronaut goes out on a space walk or an EVA to repair something on the International Spacesuit, you have to literally put them in a mobile spacesuit, which is what the spacesuits are. They're like a mobile spaceship, because they need to have temperature systems that are able to withstand extreme heat and extreme cold and keep them safe. And also it's a pressurized suit to prevent the vacuum of space from affecting them. It's also a dangerous place to put anybody in the orbit of Earth, because sadly we are getting very congested in lower Earth orbit. There are, I think, over 2,500 satellites, operating satellites orbiting Earth at the moment, and growing. And if you look at the plans of companies like SpaceX with their massive kind of constellation of satellites to provide better broadband speeds, the Starlink fleet, I think they're talking about having 20,000 satellites. So it's going to get, and I know they're very small, but it's going to get quite congested up there. And then there are, I think, about another 3,000 satellites that aren't working anymore. And then there is a load of debris. I think there's like 10,000 pieces of debris around 10 centimeters. And then there's over 1 million pieces of debris less than 1 centimeter. And all of those are like missiles hitting all spacecraft. So there, I think there has been 16 or 19 maneuvers off the International Space Station to avoid these pieces of debris coming towards them. So it's a dangerous place. There is lots of hazards that we don't even have to worry about on Earth, because we have our lovely atmosphere to protect us at all times. So yes, so you have to think of the International Space Station as kind of like a miniature city, and it has the same facilities and the same utilities as it would, as a city does on Earth. So it has to have an energy system, and it has to have a centralized energy system that provides energy across the whole space station, which we know are the solar panels. It has to have a food system and a food delivery system. So I'll talk about that in a while. It has to have a transport system. You know, it has to be able to maneuver itself. It has to be able to orbit around Earth, and it has to be able to go up and down, sometimes to connect up with oncoming spacecraft that are arriving, or to avoid debris, possible collision. Its waste system has to be very good. I mean, humans are dirty creatures, so we have to find a way of doing that. It has to protect. It has to be a structure that protects us. It also has to be a place where you can work, and it also has to be a place where you can rest. So it has to have sleeping quarters. So they're all the requirements that every structure that you need to consider, whether you're orbiting Earth or whether you're looking at habitats, more permanent habitats on celestial objects. And there's a lot in it. And so the first thing that usually happens when people test is that they will first try and understand how structures behave, or how food systems behave, or how waste systems behave, or how transport systems behave in the absence of gravity. So zero gravity flights are often used to test designs, you know, obviously on a pilot scale or on a small scale. So it's a good time for me to share my zero gravity flight, which people always like. And so it's also a very important thing in astronaut training for them to understand what that sensation of weightlessness or microgravity feels like. And I didn't vomit, but I do know that it has, it's very, it does have demands on the body for sustained periods of time. You know, we now know from 20 years of research on the International Space Station that it has detrimental effects on our muscular system, that the calcium in our bones tends to come out. out of solution, that it can have an effect on our eyesight, on our lenses. There are radiation effects from just being exposed in space, but in terms of the gravity effects, you know, the astronauts will usually have to get rid of 2 liters of fluid in the first day or so of arriving, because our whole fluid delivery system and our blood pressure system is all geared around gravity. You know, being able to push blood back up the legs, and that our fluid system gets pushed back up the legs. And in the absence of gravity, all that fluid tends to just remain around the center part of our bodies, around our stomachs and stuff, puts pressure on the kidneys. So people have this urge to go to the loo, and so they have to get rid of that 2 liters of fluid, which is fine when they're up there. And then when they come back, it isn't very pleasant. So microgravity is something that's used. And then also in terms of, it's also used for testing, like I say, food delivery systems, waste systems, everything. You have to think about, this is the world that we're going to live in. So it's the first port of call in research, researching new methods of living in space. So now we have people up on the International Space Station, and it has been a tremendous success. I know, and Mir has been as well. I mean, we have had Helen Sharman up on the Mir, so there has been collaborations with Europe and with Russia over the years. But the International Space Station was half built by Russia, and then a lot of it then was built using the space shuttle to build the America modules, and then bring up some of the other modules, like our we have a science module, Columbus, on board for the European Space Agency. And for the last 20 years, it has successfully managed to keep people alive, and it is a great exhibition of peace, in that it's a collaboration and a partnership between Russia, Canada, Japan, Europe, and the United States. And we've learned so much about how to survive in space, and so many technologies that I think we can apply back down to Earth, particularly around water purification, air filtration systems. So also space architects have learned an awful lot about how to design for humans in space. So like going back to this human-centered design idea. So we naturally think about building in terms of, you know, from the ground up, and structures, because we are totally clued into gravity. But you take gravity away, that's not an efficient use of space, when space is particularly at a premium when you develop structures. So everything you build, you think of from the human perspective. So how can the human move? What's in reach of the human? And don't forget, there is no up or down. So you can use space on the ground to store above and to the sides. So where we would have had a table and a chair, and, you know, the wall is here and this is here. Now you have 4 walls, and you have 4 opportunities for tables and chairs and things like that. And the best and the most efficient way is when things are within reach, and that there are always places for the human to rest, and to little bars everywhere for them to hold their feet and everything. So they've learned loads from that. So examples of that are, you know, that the quarters, the living quarters of the International Space Station would be different from, say, the quarters of the Salyut, or even from, say, the Apollo missions, where they really didn't have kind of sleeping quarters. And they've realized, like, that there's a whole area of sleeping bag design, and people are now, like, I've sat at conferences where people are talking about, like, comfortable pillows and how they work, and how they kind of they have to be designed in such a way that they kind of envelop the head, as opposed to it being back, because there is no gravity for the head to go back. And so you know, having your own personal quarters are important, and then the sleeping bag is a big part of that. And how does somebody get in, and how is it comfortable? And so they're all factors about the rest of humans. And then, of course, the neutral body position in the absence of gravity, or when the sensation of gravity is missing in our bodies, is very different from a neutral body posture on Earth. Neutral body posture is probably the way we're sitting now. That's really nice, you know, to be sitting in a seat, and our arms kind of relax on the armrest, if you have them, or on the table. But a neutral body position, when you are experiencing microgravity, is different. your legs are slightly forward and bent, and your arms are slightly forward, and your head is slightly tilted forward. So everything should be designed for that level of comfort. And so sleeping bags are, and a lot of this, anything which requires them to move around. Like I was saying earlier, there's a lot of monitors, there's a lot of experiments, there's a lot of activities and a lot of storage on, say, the International Space Station. So there are a few rules that kind of make this easier. So it's important to think about orientation. So even though like all sides are up for game, what you should do is up is always the same. So you don't have one side going up this way and then the other side where up is down that way, because that's confusing. So there's kind of rules where everything kind of points in the same direction, and that means that it's easier for people to orientate themselves around. And the lighting that you use and the color scheme that you use then becomes the code for people to understand which way is up and which way is down. So if we look at these two these are your classic corridors on the space station. So early on, the lights were determined as up, and then a darker color then was put in the other standoff. So you've got the dark blue down the bottom, you can see in that picture there, and then the lighting strips were up. And then they would have escape routes given by a particular paint color, and then also you would have different color schemes as well to tell you which bit is up and which is down. So lighter shades tell you that you're up, and deeper shades tell you that you're down. So you'd learn this when you're going through astronaut training, but it just becomes the code, because otherwise you don't know, and you can get very confused because you have this long string of corridors, and in order to determine which way is left and which way is right, everybody has to be orientating themselves in the same way. So that's something we never would have thought of. And so this is a case in point of what I mean. So this is one of the astronauts coming out of their own personal quarters. So there's one on the bottom, but there's also living quarters on each side and then above. So you come out of that quarter. So if you don't have a color system that you can't read from, or a lighting system that you can't read them, you need to know that. So then another really important thing is Velcro. Velcro is everywhere. Everything you have to consider everything has to be secured in such a way, because the second you take it away from Velcro or some sort of semblance of Velcro, it's going to disappear. And so many things disappear all the time. And not only is it frustrating, but it's actually quite dangerous because it can get into the filtration system. So you always have to think about objects and how objects are secured. So Velcro is a big thing, and a lot of cables and ties and boxes and things are used as well. And then the food delivery system, it has to be completely different, because again, you can't eat in the same way when you're, so this kind of food is designed for living on Earth, in Earth's orbit, but also the long-term storage of food is also appropriate for living on, setting up a long-term habitat on celestial objects such as the Moon and Mars. So a lot of the foodstuffs that are created, they are designed and engineered first and tested. And so you have standard food, which I think there's a few food production companies that specialize in them. I think there's one in Germany, and I think there's one in France for the European Space Agency. And they work with a standard packaging, and it's kind of like a vacuum packed bag with a kind of a white plastic nodule, and that nodule then connects with a water delivery system, which is on the wall, and you press a button and that then injects hot water into it. So you can make things like chicken curry and I don't know, lots of kind of wet food that is stable. And then the astronaut then usually will open it and make a kind of a diagonal cut in that in the food stuff, and then use their own fork. And then also there's tin stuff, and then astronauts also get their own special food items. So every astronaut, say for the European Space Agency that goes to space, they would work with a chef from their region. They would design it, it would be engineered, and these become special food items which they bring up, because food is a very important part of well-being when you're on long-term missions. And this is another picture of them all eating together, and this is a regular occurrence. And there's lots of customs around procedures. Every Friday night, astronauts will all eat together on the International Space Station, and they'll share food. And this is important. And these are some of the designs from Skylab. Skylab was like way ahead of its time. Like Skylab was huge in comparison to the International Space Station. Like they had a shower on board. There was a lot of empty space in the middle, which meant that they could move around an awful lot more. But it kind of became deemed as too expensive, really, and space is an absolute premium. So a lot of redesigning happened for the International Space Station, and you'll find every square meter and a centimeter of the International Space Station is used for something somewhere, and it's like a maze of storage. And down here on the left, this was some of the space food delivery systems for Skylab. Again, it was very heated serving tray, really fancy stuff. Like it's much simpler now what's being now delivered, which is interesting. I think at the time, definitely Skylab to me was influenced a lot by 2001: A Space Odyssey, and that whole Pan Am scene, which was amazing. But anyway, so let's talk about waste. Waste is a really important part of habitat design, because we are dirty creatures. So ideally, what you're trying to do is you're trying to take in, this is a kind of an assessment of the average requirements of the human versus what they excrete. So they need so much oxygen, so much food, water and food, prep water, drink, hand and face wash water, shower water, and they need a bit of clothing, right? So that's been estimated to come up to about 11 kilos. So similarly, ideally, what you're trying to do is then that a lot of stuff is going to come out of them, like CO2, some moisture in terms of perspiration, urine, feces, sweat, and different solids, and then water that can be extracted from those, particularly from the urine, water, and then their clothing, which eventually needs to be disposed of. And the idea is that should equate to the same intake. And this is all about closed loop systems. And closed loop systems are a really important part of habitat design long term. We have to think of ways of creating living systems where what goes in must come out, and what goes out must go in. So on board the International Space Station, they have efficient air purification systems, which is able to take the air and the carbon dioxide perspired by astronauts and put it through a system that can then recirculate fresh air back in. And similarly with water, and it can also create its own oxygen, and also then a waste system similarly to it. And what I think is great about this is these are all opportunities for us to look at ways for us to take this technology and apply it to Earth, and particularly when we start looking at long-term habitats on celestial objects like to the moon. So that's orbits, right? So now the moon is really heating up, in my opinion, in terms of the amount of independent countries making their play for inspiration, and also for promoting science and engineering in their country. So this is a spacecraft from Israel, which nearly got to the moon almost 2 years ago. I think it was February 2019. Maybe it was, I think it was February 2019. It tried to get there. And then last year, then we had the Indian Space Agency nearly land on the moon, and they just lost communication. So those two spacecraft, Israel and India spacecraft, are probably on the moon. They just lost communications with it, which means that there are more and more players coming into the business of space, and it's getting more and more busy. Just last December, we saw that China successfully managed to retrieve moon rock samples from its Chang'e mission, and they already have a rover on the moon as we speak. So, and we see that returning to the moon after the 50th anniversary of the Apollo mission, a human mission back to the moon is very much on the cards. as part of this Gateway, which is the next space station, which is under design, and contracts have gone out. NASA has already given contracts to some of its manufacturers, and ESA, of course, will play a role in that. ESA will provide some of the modules on board. Initially, the plan is that the Artemis mission, which is the first basically chapter of Gateway. Gateway will be simply made just for on a basic level, and what that will allow, it will be a space station that will have a rectilinear orbit around the moon, and it will then dispatch a lander, and we will have the first woman on the moon and a return of a man on the moon. It was planned for 2024, but from what I've been reading with the new administration, I've heard that there will be delays in that, so hopefully it won't be too long delays. But I know that the ministerial for the European Space Agency has given the go-ahead that they will invest in this, so I imagine that Gateway will happen. It just may not, we may not get that first Artemis mission happening by 2024. So it's very exciting. And the plan is that there will be science experiments on board Gateway. We won't always have Gateway fully with humans on board all the time. From time to time, there will be missions on board. And the idea is that there will be missions and there will be a human mission by ESA at some stage. And then long term, then after that for a few years, the plan is that there would be a lunar habitat built on the surface of the moon. And the reason I have the ESA, the Astronaut Center, up on board there is that they're involved in conducting some really interesting research about how to build a lunar habitat and the feasibility of that. And a big word that is coming out is ISRU, which is in situ resource utilization. So it's the notion of, okay, it's much more cost effective for us to think about what resources we have available on site to determine what we can build. So I mentioned the regolith, which is the topsoil of celestial objects. So the topsoil of the moon is this very abrasive surface, and at the Astronaut Center, they have like a future missions division, and they have managed to recreate a simulated version of regolith, and they're using that to test on equipment and on materials to figure out what we need to know in order to keep humans safe if we were to build a lunar habitat. And not only that, what equipment do we need to build the lunar habitat, and what do we need, what can we extract from the surface of the moon in order to keep humans alive? So they're looking at ways of extracting oxygen from regolith and also sintering it to see if they can make solar cells out of it and if they can recycle it. So this is a movie. This is a little bit out of date at this stage, but this was a concept design. I think it was shared about 2 or 3 years ago. And the idea is that there will be a mission that will land on the surface of the moon, and it will dispatch this kind of a capsule. And the capsule then will be deposited on the surface, and there will be robots also deposited. And the idea is that the capsule then will release this kind of like a tent, this inflatable kind of dome or a membrane. And then 3D printers will scoop up the regolith on the surface of the moon, and they will build a structure around on top of that inflatable dome. And the idea of that is that, you know, with the absence of an atmosphere on the surface of the moon, we're exposed to huge amounts of radiation, and also it's the vacuum of space, so there's nothing protecting humans at all. So the whatever habitat you build, you have to make sure that it is really radiation proof. So the best thing to use is to use the lunar surface that you have. So these 3D printers over a number of months will lay down layers and use that kind of bird-like this is kind of, it's simulating the way bird bone is created so that it's light, but it creates enough of a structure that it's strong enough. And then within that, then you have the habitat inside, and people then can live, and they'll be safe and protected from radiation. And there's probably a water layer there as well between the regolith and this inflatable structure, because of course water is a great insulator. And then the capsule will then be used as sort of like the airlock in and out of it. So that's one concept, but I think it's changing all the time. But I think it's a really interesting, it's an interesting kind of initial design. And like I was saying, lots of companies are connecting with NASA who have won contracts. So Blue Moon, which is a subsidiary of Amazon, run by Jeff Bezos, from Blue Origin, and this is where Brent Sherwood, who gave me those slides on space architecture, is now working. This is their design for the lunar lander to get humans down onto Earth. And then we're seeing SpaceX. Only last night we saw another test flight of this huge spacecraft, Starlink, which has aspirations to launch to the moon, and yesterday even announced that it wanted to bring creatives to the moon, thanks to a Japanese billionaire, Yusaku Maezawa. And yes, I have applied, and I think you all should as well. So, and then let's go on to Mars. So then the idea is that lunar habitat then will be there probably for science experiments to learn again, what do we need to know if we are to have a human habitat on the surface of the moon. If anything goes wrong, we've already learned from all of the rovers and stuff that we've sent to the moon, and this is what we've learned. And so now, if anything happens on the moon, if anything goes wrong, we're only 2 to 3 days away. But ultimately, we really want to bring humans to Mars. I think for science, I know that Elon Musk has aspirations for us to colonize Mars. That's not really what I mean. I'm thinking about for science experiments, because to put humans on Mars means that we can really kind of ramp things up. So some of the things that I like about some of the rovers, this is the Curiosity rover. I love that it's shown us a sunset on Mars, which is amazing. Like the sunset has a blue sky as the sun sets, whereas we have a red sky. And then of course we've seen Earth in the night sky of Mars in the same way that we see Mars in the night sky. And it makes me feel a sense of there and here whenever I see these pictures. And this last month just gone was Mars month. We saw again more and more countries getting involved in missions to the Mars. We had the United Arab Emirates HOPE mission, which is orbiting. We have the Chinese arrive and they will ultimately land a rover on the surface of Mars for the first time, TION-1, which they're looking at icy deposits in the rock. And then, of course, we have the Perseverance rover with its 23 cameras on board, which has already given us huge joy and codes in parachutes and amazing landings and stuff like that. And, already we are learning more and more about how to safely land rovers on Mars. So that the amount of activities that are happening at the moment is incredible. And a big part of Perseverance mission, yes, it's to take pictures and it's to find these biosignatures for the origins of microbial life. And it's there in the GATEWA crater because that was they believe a lake, and so there could be sediment there to show signs of life. But also the Perseverance rover has some technology on board to see if it can use again if there are any opportunities for this in situ resource utilization. So MIDA, which is the Spanish experiment on board, is involved in determining what the weather conditions are like and what the dust is like, because we need to know what Martian dust is like and how will it impact on spacesuit design. And then underneath there is an experiment called MOXIE, which is running an experiment, a demonstration test to see if it can extract oxygen from the atmosphere, from carbon dioxide and from the soil samples as well. So again, the Perseverance rover is there for the first tentative steps for human missions, and of course it will be taking drilled samples and returning them to Earth thanks to working in partnership with ESA on its sample return mission. And all of this in order for us to one day have science experiments conducted by humans on the moon and on Mars. A big part of that, yeah, of course, we have this grand gesture. I sat on this on this lecture, that this legendary lecture that Elon Musk gave in 2016 at the International Astronautical Congress in Guadalajara in Mexico, when he laid out his grand designs to have a civilization on Mars in 100 years. It beggars belief, what he was saying. But then everything he says he's going to do, he's already done. So who knows? But what Brent Sherwood told me is that space analogues really are important. And space analogues are where we go to extreme parts of our own planet, and we use zero gravity flights to figure out what we need to know on Earth as best we can before we put humans in danger. So how the operations affect design, what it's like for humans to live in isolation and confined, and what's it like conducting experiments in the absence of the everyday things that we take for granted on Earth. And this is where I will share a little bit about my own simulated Mars mission in the Utah desert at the Mars Desert Research Station, which is a facility run by the Mars Society. It's over 20 years old, and it's kind of a broken down, which I kind of liked, because it made me really see that when you are living in the absence of the day-to-day luxuries of running water and food shops and electricity and all the utilities that we take for granted, everything gets really complicated really quickly. So we simulated conditions as if we were on Mars, which means that if you were to live on Mars, there is a very thin atmosphere of carbon dioxide, 95% carbon dioxide. So to simulate that, every time we went outside, we would wear a spacesuit. It's not an actual pressurized spacesuit, but it was a nod to actually just suiting up to give the sensation of how incredibly uncomfortable it is and how difficult it is to even take samples when you're wearing that suit. And we went in with a ration of water and a ration of food, and that was hugely enlightening for me. Our mission was to kind of come up with this kind of proof of concept about, we had this model brick that we wanted to 3D print, and we wanted to build a wall and kind of and prove the design of the wall when we were there. And we also wanted to see if you could grow food on Mars under artificial light. That's basically what it was. So this was the crew. There were astrobiologists and engineers from Israel, Slovakia, Australia, Morocco, and then myself. And all of them were very well respected in their field. I was there as a science communicator, which is what I do, but with the engineering and science background, I'm able to get involved in the experiment side of it as well. So this is us here. We took lots of pictures, because for me, it was always about the public engagement and the outreach part of it, and trying to share the human message of this, which is something sometimes I find in these experiences, these human experiences, that we can kind of tend to overlook, because the science always has to come first. But if you're really trying to engage the public and trying to get people to come up to speed on all these things that are happening, I believe my purpose in life is to kind of share the human story, because it makes it relatable. You don't necessarily have to be science literate to engage in it. So this is where we were. Obviously, the location is hundreds and hundreds and hundreds of kilometers from any sort of civilization. There's one tiny town called Hanksville where you get your petrol and your food delivery before you go in, but other than that, there's nothing. It's surrounded by national parks. It's a paleontologist's delight there. There's been lots of dinosaur fossils and everything found there. And so the government apportioned a bit of land to the Mars Society for this facility, because the geology and the landscape is Martian-like. So it allows geologists and astrobiologists to conduct experiments in the field and to prepare them for what difficulties they may have if they were on Mars or on the moon and trying to conduct experiments in the field. So this was what the facility looks like. So we had kind of 3 or 4 parts to it. We have the habitat, which is where we lived. It's a 2-story facility. Then we had the green habitat, which is the greenhouse. Then we had the science dome, and then we had the observatory. We didn't really use the observatory. Our mission had nothing really to do with astronomy or astrophysics, so we didn't really use that. But we used the science dome a lot because we took a lot of geology samples and astrobiology samples, which we had to test, and also for printing our 3D bricks we needed the 3D printer, and also we needed to use regolith of a certain sieve size. So we used the sieves, and we did tests and everything on the carbonates in the soil samples, because that's what you would do to determine if water was present on the surface of Mars or on the moon. And so the only other part then is you see the tunnels. It's a tunnel, because that would be what you would have on Mars. It would be an underground tunnel, and it's the only part of the facility outside that you don't have to suit up, because it was extraordinarily cumbersome to be suited up at any time. So this was our mission, to build home on Mars. We had estimated that this was the on-site 3D printer, which was pretty basic, and we had estimated with the cartilage and the filament that it should take about 17 hours to print one brick. So we had kind of reckoned that while we were there, we would definitely be able to print about 43 bricks if we did it back to back. Didn't really work out that way. This was our most successful brick. And we'd run out of green filament, and we were turning over to white filament. At this stage, it was probably one of the most exciting things of our day. And this was the 3D printer that we used, and it was just fraught with one problem after another. We got loads of rock samples, and we sifted them, and we had all the right soil ready to go to fill our 43 bricks. But this was the sum total of what we actually managed to print. And this what is such an important part, I think, of what you can learn from habitats and from analogues, is that you have to get realistic on the timelines and your experimental schedule, because everything breaks down when you leave Earth, because everything is difficult. Even just getting up and feeding yourself and keeping your habitat clean and scheduling EVAs, all of that gets difficult. This is the habitat. So the ground floor is where the airlocks were, where you would go in and go out, and then you had an engineering airlock. That's where you would check your water levels every day. You had to report to mission control on your water levels, your food levels, your power levels. You had a very low level bandwidth of broadband that was available for 2 hours. It was excruciatingly slow, and it was my job also to try and keep some sort of public engagement going on social media. So I had to kind of downsize photographs. It would take me hours every day. Upstairs we had our living quarters. I'll show you all that now. And that's where we ate and where we slept and where we also did our computer work. So these are the tunnels that I was telling you about. And they take you from the main habitat to the science dome, to the observatory, and to the green hub. So this is the corridor to the science dome, and it's an okay. It's not a bad kind of science dome. You know, it had everything you could basically need. There was a lot of soil sampling, a lot of sieves. There was some wet lab facilities available there, but to be honest with you, it was very difficult to keep anything clean. The red dust came in everywhere. We would use slippers in the habitat to try and keep our living quarters as clean as possible, but it's impossible. And when it rains, it becomes this very sludgy, slippy mud. And you couldn't even go out on EVA when it rained. It was so dangerous. So this is the back entrance to the facility. This is the engineering lock. So you see there, you've got the white canisters. That's our water. So we had 2 there, and you have another one there, and you would feed that across using a pump. You can see how old the facility is. So that's the engineering airlock. And then you come out of the engineering lock. I'm leaving the toilet right now, which was disgusting. We only flushed the toilet for number 2s and not number 1s. There was a shower there, and I used it once for about 3 minutes, and it was just, there's no point, because the power in the pump of water was mad. It would just go and it was extremely uncomfortable, and that was the kind of the pressure of the water when you would go to wash your hands, when you flush the toilet, when you'd go to wash up or have a drink of water. So that's our equipment for suiting up. You see there's a helmet, then there's like a rucksack which kind of connects with the helmet, and the purpose of the rucksack is there's a fan in it, and it's supposed to keep the interior of your helmet free from condensation. Again, a very old facility, didn't often work. You had to charge the rucksacks every night. You had to wear a radio every time you went out on an EVA as well. And so there was a lot of charging that you had to do. So a lot of procedures, all extremely time consuming. And this is the living quarters upstairs. So we had one little tiny part of our own private space. They were called like, what was it called? Some stateroom. I mean, hilarious. And the couches was where we did our computer work. We had a ton of reports to do every day. That's also where we ate. We used the table for eating. We also used it for a lot of our own kind of admin work as well. This was my own stateroom. There's no windows, obviously, because on Mars you wouldn't have a window. Every time there's a window, it's a threat of pressure leak. I brought all my kind of camera equipment with me and everything that was on the packing list, like a sleeping bag, and you have to bring salopettes for skiing because it's so cold there. So you really had no space to bring anything personal at all, no personal effects. And this was the kitchen, and that was nice. You know, that was the most kind of earth-like thing that we had, and this was what we ate, because again, this is the kind of food that you would have to bring if you were on Mars, kind of shelf-stable food, dried egg, that is dried egg, dried potato, dried broccoli, and so you'd add water to it. Thankfully, I don't have any taste buds, so it didn't bother me at all, but the food was extremely salty. And we had a rota where we took turns in cooking, lunch and dinner and cleaning, and to save the morale of the team, I quickly swapped out a dinner and took everybody's cleaning duties, because the place was filthy and I couldn't bear it. I had to clean every day. And so I think for their sanity as well, in order for them to eat something decent, it was a good idea to swap over. So the growing food on Mars experiment was, what we did was we compared growing spinach seeds and in the green hab versus under an artificial wavelength of light in a solution that was seeded with the same nutrients that should be in soil, to see, can you grow food on Mars. So the green hab was kind of where Rick hung out. He was an astrobiologist, because Rick also then planted food for subsequent missions. So we were Crew 173 and the mission after us was Crew 174. So he planted lots of veg and salads and stuff, and he asked them if they would continue to water them after we left, because we were only there for 15 days or so, because a day on Mars is slightly longer than a day on Earth. But of course, we didn't actually manage to do that. They forgot to water the plants, and that's typical. And then you had Michaela then, so she ran a comparison of it. And what we found was the seeds did actually germinate, but it takes a very long period of time. And then the EVAs were the most, they were the most kind of out of this world kind of sensation, if I'm really honest, that we had. And every time you would go on EVA, it would take your 2 crew members to help you put this stuff on. You'd have to wear very heavy boots, gloves, and the second you put that helmet on, it was extremely uncomfortable and cumbersome, and your center of gravity was off. So even though we haven't even left Earth, already you're running into all these technicalities about living in an environment that is not conducive to day-to-day living. And it gave me a real understanding of how difficult it is to survive the second you leave Earth. Now, we haven't even got a gravity issue. We haven't even got an oxygen issue when we walk out that door. Just even wearing these cumbersome suits, everything gets extremely difficult. Like even driving, see that there, then you're driving these sort of ATVs in this really heavy suit. You're trying to climb up hills, also really difficult. And then trying to collect samples then with these cumbersome gloves, everything became really difficult. And I had camera equipment on top of that. The day just flew. You'd get up at 7 o'clock in the morning and you'd have a plan to do something, and by lunchtime you are way behind. You were always behind. I had GoPros everywhere, so I was constantly downloading content from the GoPros, emptying them, saving them, and then charging the GoPros. We had a ton of activities to do every day. We had to also kind of publicize what we were doing. I was taking a ton of pictures, as you can see here, always taking pictures. And then on top of that, trying to remember to keep the water levels going, our reports every day, eating. You'd get up in the morning at 7 a.m. and you would not stop until about 11 p.m. And you were constantly juggling between just everyday life and then trying to get your job done. And then at the end of the day, then you would rest. And this is what dinner was like. And then suddenly you would come to the end of your day and you would then go to sleep at maybe 11 o'clock at night. And then the mission is over. It flew. And I was constantly dehydrated. I had headaches the whole time. I completely forgot about what life on Earth was like. And it was a life-changing mission for me. My whole perception of my water usage, everything changed. I downsized. I came here to live in Strasbourg. Everything changed. I now live out of like a storage unit back in Dublin. And I just brought one suitcase here because I realized that there is so much that we can learn about space from just that one thing. I'll stop there because I'm conscious of time. But yeah, so that's where we're at in terms of what we can learn from habitats and living off Earth. Back to you.
That was fascinating, Niamh. There's so much. I have so many questions, but so do all of our participants here. So I'm going to let them start. But that sounds amazing. And I have to say, the zero gravity flight looks like a lot of fun. A lot.
Yeah, it was fun. It's scary, but fun. Yeah.
So yeah, we've got a few questions about the ISS. Start off with a nice easy one. What size is the ISS?
The ISS is the size of a football field. It is huge, but it's mainly the support structure. So that size also takes into port. So you've got this truss going on the horizontal, and that has all the solar panels, and then the actual part that kind of looks vertical is where all the power systems are and the support systems and where the humans actually live. But actually it's space. If you were to drop it down on a football pitch, it would take up the whole size of a football pitch. It's huge.
Okay. So it's pretty big, but like it's not filling that entire space.
No, that's right. Yeah.
Pretty big. Okay, great. So I know there was some news recently about ESA launching their ask for new astronauts that can apply to be ESA astronauts, which is brilliant because obviously Ireland is a member of ESA, so people can apply, which is amazing. But somebody was asking a question here. Do you think the ESA astronauts will be part of a Mars mission, or is it too soon to bring humans there?
It's too soon to bring humans there, but if I go back to this slide, so if you look at what the plan is, everything is about ultimately getting human missions to the moon. If I go back to this slide here, I'll just share the slide. If you look at this one here again, just 2 seconds, this one. This is it. The journey to Mars everything is about this. So this is NASA's mission in terms of what it's providing in terms of space science. But all of the agencies are kind of all working together. They understand that it's too expensive for them to do it on their own. So just like the Gateway, which is happening now, you've got the European Space Agency involved in the Orion, which is the human delivery part of getting humans to the Gateway and other modules on board. So we'll do that, and then there'll be a lunar mission, and then in like 10 or 15 years time, then they'll start telling us about what is the orbit, what is the human space station that's going to be orbiting Mars. And I imagine that the same agencies that are collaborating now will continue to collaborate going forward. So I can't see why ESA won't be involved in that.
Yeah, and this is a great example of science being done better when we all work together, really.
Well, yeah, and we have to, because it's just getting too expensive as well.
Yeah,
the only way
it's such a huge endeavor that all these agencies need to work together, all these countries. The ISS is the International Space Station, and it really is international, isn't it?
Yeah, it's brilliant.
But you mentioned Gateway there, which you talked about earlier as well. What will happen to the ISS when Gateway is built? One of our attendees would like to know.
I think ISS will continue. So if you notice, what's happening is that there are, in the last even year or so, you're getting more and more commercial activities going to Gateway. So you had baking in space, obviously I'm obsessed about that. So cookies were baked in space last year, and there are opportunities to dispatch more and more kind of commercial experiments on the International Space Station. Bigelow they've collaborated with the International Space Station to provide an inflatable module, and their notion is to conduct their own private enterprise experiments working with companies, and also ultimately to have citizens go up in space. Axiom Space has also partnered with the International Space Station, and they want to build their own module for them to provide public or space tourist opportunities. And you saw there in the news at the top of the year, Axiom Space have already announced 4 billionaires who will actually be going to the International Space Station, I think at the end of 2021 or 2022. So it'll become more and more of a commercial enterprise, and there's been a lot of technologies that have developed from us understanding how to take advantage of this microgravity. So, we see that flames behave differently in microgravity, and that growing cells and proteins are far more uniform. So it's going to become like a hub of technology and manufacturing. So I think it'll still exist. And I think there'll be more space stations as well built.
Yeah. Okay. And I suppose because it's close enough to Earth, although it is a big deal to get there, it's easier to get to than the Gateway will be, or the moon.
Yeah, exactly. Yeah.
Brilliant. And also actually on the ISS, which is a brilliant thing. Somebody here is wondering about the color schemes. So you mentioned that they have the color schemes to try and tell up from down and when you're in the topsy-turvy. But in the ISS, how did they decide the color schemes? A question I would add to that is what does that people who have different needs, like color blindness and different?
Yeah, it's if you talk to space architects, they're dying to get at it because they feel like that there needs to be more stimulation for astronauts on the International Space Station. There's a lot of white, there's a lot of harsh lighting, there's a lot of kind of strip lighting on the International Space Station, which makes it very hard on the astronauts. So they are like architects would propose, like when you go to conferences, it's amazing to sit in on the space architect lectures, because they're coming up with lots of novel ideas of better color schemes to use. But at the moment, it's a bit of a hodgepodge, to be honest with you. And there's just a few kind of codes of conduct, which is that the lighting on the top tells you it's up, and then the standoffs in the corner are a darker color. And the Russian color scheme is different from the Russian half of the International Space Station are kind of greens and yellows, whereas the European and the American side is kind of whites and blues. But yeah, there's loads more we could do. Loads more. And I agree with you, the color blind thing, and just even making that space feel more homely. There's lots we could do with it.
Because these people live there for months.
Yeah, well, some of them even live there for a year.
Yeah. So yeah, it could get a bit much.
Yeah.
Also on a similar topic, you mentioned that they have like a Friday night dinner or something. What kind of time zone does the ISS follow?
Always GMT. So the time zone is UTC. UTC it's always GMT. So everybody agrees that everything on the International Space Station is GMT. So it's always our time, which is kind of
because they don't really experience day the same way you do on the planet, because they're spinning around us, right?
Yeah, that's right. Well, they get a sunset and a sunrise every 90 minutes. So they see 16 sunsets a day.
So you just have to have a watch telling you when it's nighttime and daytime and sleep time and eat time.
Yeah.
Very good. Very strange place to be. But yeah, you mentioned space architects quite a lot, which is obviously something very cool.
Yes.
Somebody here is wondering, what do I need to study to be a space architect?
Well, I think so I know an Irish space architect, and her name is Orla Punch. So what she did was she did architecture in UL, and I'm sure you can do architecture in UCD as well, and the different places where they do it. And then for her 4th year project, she proposed to design a Mars habitat. Now, she said they thought she was insane, but they let it happen, and she ended up getting the gold medal actually at UL for her design. But in Ireland there is no space architecture degree, but what you can do is you can combine it, and you can do things like, so the International Space University, they would have a master's in space studies. So what you can do is you will have exposure to space architecture within, I think, the humanities and the engineering lectures. So you can do that. And I think that in the US there are some universities that are now offering space architecture. It's fascinating.
Even, I suppose, there's probably subjects that you could do going into at an undergrad level that would be really relevant.
Yeah,
like engineering, physics, astrophysics, that sort of.
Yes,
probably mostly engineering.
Yeah, absolutely. Yeah.
And then similar on the studying, Orla was wondering what subjects, languages, skills would you recommend studying to work towards a good space engineering career or being an astronaut?
Any science subject. So half the astronauts in this current core are scientists, and then other ones are pilots. So you have a geophysicist, and you have engineers, and a material scientist, a geophysicist, and then engineers. So any of those subjects, it's what makes an astronaut is more about their tenacity and their ability to take on huge amounts of pressure and being calm under pressure, and kind of having that ability to lead and to follow. So a primary degree and a master's degree in a STEM subject is a fantastic foundation. And in the early days of space exploration, you know, for the Mercury mission that I was that we were talking about there, and you know, all the Roscosmos missions at Uri and stuff, they came from test pilots because they were the only people that were specialists. But now it's more about the science, and it's about the research. So they really need astronauts to be capable of conducting experiments on board the International Space Station, and probably Gateway, and probably the lunar mission. So a really good degree in engineering or science is a fantastic way to start.
Okay, and I guess as well, I mean, I don't know what age Orla is, or probably looking at what you should study now, but even looking at the current call for astronauts from ESA, seeing what minimum requirement there is would probably be an indication of what they're looking for their astronauts.
Yeah,
and like you said, it's a much longer process that you go to train to be an astronaut and see how suitable you are, but the bare minimum is basically like a science degree and stuff.
A master's degree and 3 years experience afterwards. So ideally you need to be kind of mid to late 20s. Ideally, astronaut selection is kind of 27 to 35. Like, that's really the ideal age group to be in. And there are exceptions, but that's kind of it. Like Paolo Nispoli was, I think he was kind of late 40s when he was selected, and his first mission, I think, was in his 50s, and he just had a second one there and he's in his 60s. So there are exceptions. And Peggy Whitson as well, she was in her 60s when she went up. But ideally, if they're going to invest in you for, you know, a number of missions, it's going to be about 20 years. So they're looking for people kind of late 20s, mid 30s.
Okay, so as your last.
Yeah.
And on that vein, somebody here is wondering if you think astronomy should be taught for the Leaving Cert.
Oh, wouldn't it be brilliant? Well, yeah. I mean, I think it would be lovely for. Yeah, I think there should be more space included in the science subjects. You know, physics, I think, even could have more space in the curriculum. You know, I'm sure Sophie would have a lot to say on that as well, you know, because astrophysics and astronomy, I think, like, I know from all the talks and stuff that I give, and you're probably the same, Áine, and you're probably the same, Sophie, is that there's this natural fascination with space, and it's a great way to engage in science. And, you know, we all look at the moon, we're all kind of wondering what we're looking at in the night sky. So I would love to see astronomy taught in the Leaving Cert.
Yeah, I think the junior cycle, the junior cert course was a few years ago, and it includes quite a lot more of Earth and space. Yeah. Astronomy. So I suppose that's going to hopefully trickle through.
Hopefully, yeah.
Even just in the core physics course of Leaving Cert.
Yeah, it'd be great, wouldn't it? I would have loved it. Like, I would have loved it if I was in school. Yeah.
But okay, so we've got some questions now about your Mars Desert Research Facility and your time there.
Yeah.
First of all, a nice quick one. Emma is wondering if the Mars Desert Research Facility is on Google Maps.
Yeah, it is. Yeah. So look around. So it's in the state of Utah. The nearest city to it is Grand Junction, and then you look for Hanksville and you'll see that it's off-road in Hanksville. It's very near Hanksville. Yeah.
So yeah, you could probably get the kind of aerial
You
view
can get,
there.
yeah.
Nice.
Yeah.
Okay,
It's
great.
stunning.
And from your experience doing that, did you feel claustrophobic working and living with the same people all the time? And this person makes a very astute observation that I guess it's kind of like a COVID lockdown. And then also, would Mars missions have to be careful what personality types would be chosen to go together?
Absolutely. So there's kind of three questions there. So did it feel claustrophobic? Yes. I was very worried about that, to be honest with you, because I was a good 20 years older than everybody else, you know, because I've come late in life to this new career of mine. And so I like my space. Do you know what I mean? Like I'm good on my own. And I think I'm an introvert. So what I find is like I'm great in public, but I always need time on my own to kind of reboot. And so I was worried about that. And it was hard. It was really hard because you had to put the needs of your crew first, because if you didn't, everything would break down. So it was exhausting from the moment you got up to the moment you went to bed, because you were concentrating on a level that's excessive to what you're used to on a daily basis, because you're trying to think as a team all the time, and you're also being bombarded with new experiences all the time, and you're trying to adjust without getting stressed or overwhelmed. And sometimes some people would have a bad day, and because you're trying to work as a unit and there's nowhere to hide and there's nowhere to go, you'd sense it straight away, and you'd go, you know, and it would, you know, we were very lucky. We got on, like I kind of brought the giddies, like I kind of started laughing at things and we kind of laughed our way through things. But there was a few times when it could have kicked off and it didn't, you know, but it's very tiring to be focused that much. And I mean, like, I can only imagine how much more focused you have to be when you're trying to survive in the dangerous environment of a tin can that's orbiting Earth, and trying to concentrate on an experiment that's cost millions and has the investment of hundreds of people that have asked you to conduct this experiment.
No pressure.
So yeah, exactly, no pressure. So I know that Bob Thirsk would say, you know, the Canadian astronaut, he said that he felt that pressure all the time, because you're there to fulfill the needs of a lot of other people. So I felt that pressure, and this was all, I mean, the stakes were nothing. So it really gave me an appreciation of the pressure that it's under. And then the other part of that question was, what was it again, Áine?
Would Mars missions have to be careful what personality would be chosen to go together? So it's always like you have to have the right personality. That's why they do things like the simulated Mars mission, or going to the Antarctica for a few months where you're isolated. Yeah. This is also asking about personality types together, not just suitable to travel and be in.
Absolutely, yeah. But I mean, you even on board the International Space Station, like they're selected, those crews are selected, and they're put in teams. So you do basic training for 2 years if you get selected as an astronaut for a space agency. And then you can wait around, you can do CAPCOM, which is communications with the International Space Station, and other things around the agency. And then you get the call that your mission is up. And so you and whoever the two other people that will launch with you, or three at this stage now, because of Crew Dragon being able to take 6 people, you would spend about 2 years training with those people. And so you understand each other, you work together, you know each other really, really well. So that happens years before you eventually end up on your mission, for that very reason. Because, you know, in the past, there has been some crews that haven't gotten on. I've spoken to a few surgeon generals who are for different space agencies, and there has been fisticuffs, and there has been fights, and there has been, there's always a psychologist on call all the time. So even when they do that, you're under huge pressure, you're very tired, and you're getting very little time to yourself. So yeah, it's very, very important that psychologically people are matched properly.
And you can't really like go outside to blow off steam, go for a walk.
Nowhere to go. You've got a little,
because your room is a sleeping bag.
That's right. But that's it. That's the only private space you have. But you'll only get to that for like the last hour of the day, Now, thankfully they can, communicate down to earth to their family and all that kind of stuff. But all of that is on their free time. And when you visit the Astronaut Centre, when an ESA astronaut is on mission, you see this, like, it looks like a kind of a school timetable, and there's this red line, and the red line is what they should be doing every minute. And so it's like experiment, blah, 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 and then lunch, and then exercise, and blah, blah, blah. And every second that they're on the International Space Station, it's time, because it's so expensive. And if they fall behind, which they invariably do because things go wrong, in their free time, they have to use that time to catch up with the red line. So when they go to bed, it's only after they've caught up with the red line. So
wow,
it's incredible.
Okay, so that's a bit talking about the psychological challenges, but physical challenges. One of our attendees here is asking, how long do you think somebody would be able to survive in space at a time from a physical point of view, in terms of muscle mass loss, reshaping the heart? I know there's bone density loss as well, all that kind of stuff.
Well, it's very difficult, and they did an experiment. It's a very interesting experiment. Scott Kelly, NASA astronaut, and I can never think of his first name. Mirchenko, a Russian astronaut. The two of them spent a year in space, and Scott is a twin, and so his brother Mark was on Earth, and so it was a perfect kind of twin study to see like how it affected him. So he was over a year in space, and so his body really suffered. Like, you should read his book Endurance. It's amazing. Like, the opening chapter is that it's Thanksgiving, and I think he's home a few days, and there's all this swelling in his ankles, and it's like if you push it, it's like a massive blister.
Oh God.
Yeah, because his whole lymphatic system and his whole fluid system hasn't adjusted to Earth at all.
So it's like your body tries to adjust to the weirdness of being in space, and then all of a sudden you come back to Earth and it just doesn't know what to do.
Well, gravity, if you think about it, you've been living in the absence of gravity, so your fluid has kind of just been, your body hasn't needed to do anything to get
to
fluid.
Pump things anywhere, yeah.
No, it doesn't. It just kind of all stayed around the middle of the body, and then you've gravity pulling it down. So all the muscles and the tissues and the vascular system that is used to pushing fluid back up the body hasn't been used in a year. So fluid retention is a massive thing. The vestibular system is really confused. So even if you're on a mission for 2 weeks, seemingly the vestibular system. So the vestibular system is our inner ear. So you have you naturally understand, because of the force of gravity, the 3 dimensions of space of Earth. Up, down, and forward and back. So we understand height, width, and depth, basically, and that's because we have 3 components in our inner ear, our cochlear system. And that tells us which way is up. So when you're floating around in space, you can't see at the horizon. So your vestibular system gets completely confused. So when the astronauts land, not only are they seriously dehydrated because they're missing that 2 liters of fluid that they had to get rid of, their muscles are extremely weak because they've been trying to work out for 2 hours a day to keep them strong, but they're not used to this pull of gravity. And also they're extremely dizzy because their inner ear isn't working, and it can take up to a week for you to stop feeling dizzy. And astronauts, if you see them when they arrive, they come back and they wave, and they don't tell you that they are in excruciating discomfort.
Yeah. Yeah, I mean, it's such a physical toll, isn't it?
Yeah.
Wow.
They're incredible people. They really are.
Something equally as important, I think, somebody here is asking, would Nutella survive in space?
Nutella, yeah, Nutella would definitely, because look at the texture of it. Yeah, absolutely, that'd be perfect. And peanut butter as well. So a very common way of kind of having a snack are like those wraps, like the flat things. So they're very
Okay.
popular. And then, because you can spread peanut butter and you can spread Nutella on them and you can eat them because there's no crumbs. So anything that doesn't have crumbs works. But you remember this, Áine, from the show Baking in Space. It was really interesting hearing Helen Sharman talk about how they ate. So she, like the Mir space station was fully Russian. So they had a kind of a table and a hot plate. And then they had this kind of a grill section, which was kind of like a Hoover. So so you would eat over this because it would automatically kind of suck any crumbs out of any food that you would have, because crumbs would really destroy filter systems and stuff. So everything is designed in such a way that Nutella would be perfect because it wouldn't actually have crumbs and you could easily spread it on a wrap. So that it's a good one.
They wouldn't try to dehydrate that before sending it up for anything?
No, I don't think so. Like peanut butter and Nutella and things like that would work.
Okay.
Honey behaves very strangely in space.
Oh, yeah?
Yeah, somebody showed me honey in space, and it was like it kind of follows a line, like, so where water kind of is a blob, you can kind of make lines of honey and it stays in the lines.
Ah, okay.
Yeah.
That's to do with its surface tension being different.
Yeah, because it's so thick, I think. Yeah, it must be because it's so thick.
Viscosity, yeah.
Yeah,
Wow, honey's just brilliant.
honey rocks.
Yeah, I was hoping you were going to say it would just automatically form hexagonal structure.
Oh, I wish, yeah. Probably would over time, though.
Yeah, I mean, well, you could do the line and hexagon.
Yeah.
Okay, great. We've got lots of comments saying how fascinating this has been, how much everyone has learned.
Oh, good.
I also would like to know, could rovers be placed on other planets? So obviously you were talking about rovers on Mars. And well, there's some stuff like that on the moon as well, but on Mars.
Mars, yeah. The other problem is, you have to have a surface to be able to put a rover. So like Sophie, chime in here. Venus has a crazy atmosphere. Like it's really, really thick. It's like thicker than the ocean. So you could only really put it on the top of the so you could get through the upper atmosphere, which is like Earth's, but then you could actually only like sit it on top of the next part of the atmosphere because it's so dense. And then Jupiter, of course.
I think also one of the biggest problems of putting something on Venus is the heat.
And the heat, yeah. And then, I guess you could put them on some of the moons of the different planets. Okay. But
and Jupiter, you're saying, it doesn't really have a surface.
Well, it eventually has a surface, but there's a lot of cloud and a lot of gas and stuff before you get to the surface of Jupiter. So there's a lot we don't know. Sophie, chime in here.
Maybe one of the icy moons or something.
Yeah,
there's like a hard ice, but all the other ones, the gas giants, you're just not going to get anything landing on there.
So when it comes to talking about Jupiter and Saturn, you're probably better off going for some of their moons rather than the actual planet, which also seem to be more likely to hold life.
Yeah, like a Titan or a Europa or something.
Yeah, okay. And we're going to stick to planets within our solar system, because the challenges with putting rovers on planets outside is actually getting there far too far away.
Yeah.
All right. Yeah, we just actually have one more question about your visit to Baikonur.
Baikonur, yeah.
Yeah. What was it like to visit, and did you get
amazing
there?
Did you
get to see any rockets? You actually saw a launch.
I did. I saw a launch of Alexander Gerst, and I went back to his return as well when he returned to Earth. Baikonur is amazing. If you ever get a chance to go, I cannot sell it enough to you. You see, because we're Westerners and we speak English, we know an awful lot about NASA and the history of NASA, but we kind of don't really applaud Russia enough for really being pioneers of space exploration, particularly human space exploration. And it's really interesting. They're really good at memorializing all the different people, and the museum in the Baikonur Cosmodrome is incredible. It has the spacesuit of Yuri Gagarin, of Valentina, Laika, the dog. It has the actual seat that they put Leica in. It has all these walls of signatures. I mean, if you're into space at all, oh my God, it has the Buran. I was in the Buran, and the Buran, for people who don't know, is they reckon that the Russians stole the design, the blueprints of the space shuttle, and they built one. And they call it the Buran, and they have the Buran there, and so you can get into it, and it's incredible. And then, you know, once you know, so Baikonur is a city within Kazakhstan, because Kazakhstan, of course, is part of the former Soviet Republic, and so Russia still owns Baikonur. And then you go into the Cosmodrome, and the Cosmodrome is like kilometers and kilometers and kilometers of steppe desert, and there are lots of different launch pads for different things, you know, so they're launching for satellites, and they're launching for different you know, for different commercial entities. And then you have the infamous launch pad 1, which is known as Gagarin Start, and because that's where Gagarin launched from, it's where Valentina launched from, and of course it's where all humans launched from. So, and the other thing is that you can get up much closer to launches there. Like, I was only 800 meters away from the launch. You wouldn't get anywhere near that when you go to Kennedy, when you go to Cape Canaveral. Like, they say that the nearest is 3 miles away. So you felt it. I felt it in my stomach. I felt the heat of the rocket. Like, you'll see from my footage that the camera shakes and it rumbles. It was an incredible experience.
Wow, that's amazing. Okay, so it's on the bucket list.
Absolutely, do it.
Niamh, thank you so much. We could be here for hours. We've on a bit longer than planned, but
sorry guys, yeah,
we could just sit here and chat about this and hear, and the same comments are coming in. People would just love to listen to you talk about all this for hours, but we'll let you go and get some sleep.
Okay.
All right. Thank you so much for joining us, and thank you to all the attendees for joining us as well. This really wouldn't work if it was just me and Niamh, so thanks everyone for being here and joining in the conversation and bringing all those wonderful questions. If this is something that interests you, which it seems to, we have other events coming up as well with I-LOFAR. We've got an event to mark the spring equinox later on this month.
Oh, lovely.
On our social media channels and on our website for details of that. And yeah, thank you so much for joining us. Niamh, I've got more questions. I'll be sending you an email.
Thank you. Thank you, Áine and Sophie. It's always a pleasure to work with you. So thank you very much.
Fascinating as always. Thanks a million, Niamh.
Thanks. Bye.